Crash Course Instrumentation, Ep20, Electrical Symbols and Standards. Decode the drawings, speak the language. Intro. Ever look at a diagram and wonder why one resistor is a zigzag and another is a rectangle? Welcome to the world of electrical standards, where symbols mean everything. In this episode, we're breaking down the two biggest players in schematic design, NEMA, used in the US, and IEC, used internationally. And since this is Crash Course Instrumentation, we'll also go deep on loop diagrams, because those little bubbles are the secret to understanding entire systems. Why standards matter. Imagine trying to troubleshoot a motor circuit with a diagram in another language. That's what it's like when symbols don't match your training. Standards aren't just guidelines, they're how we avoid mistakes. Electrical safety, maintenance accuracy, engineering efficiency. Students who learn both NEMA and IEC are bilingual in schematics, something many working techs still struggle with. Quick history: the NEMA and IEC standard evolved alongside industrial America based on graphical representations of real devices. Think coils, switches, relays. Meanwhile, the IEC took a more abstract approach. Symbols are geometric, modular, and designed for international use. Side-by-side symbol examples. Let's decode some common components. Resistor. NEMA, zigzag line. IEC, simple rectangle. Push button, no. NEMA, horizontal bar with arc. IEC, circle with vertical line. Relay coil. NEMA, a loop or box with label. IEC, circle with identifier. SPDT switch. NEMA, mechanical lever style drawing. IEC, angular lines with connection dots. Fuse. NEMA, squiggle in a box. IEC, simple rectangle with line through. You'll see these differences in every corner of the control room, from cabinet doors to PLC inputs. Loop diagrams and instrument bubbles. Now let's zoom in on loop diagrams, arguably the most important schematic in instrumentation. These tell us what device is installed, where it gets power or signal, whether it's sourcing or syncing, what wire connects where loop bubbles contain function, location, signal type, and tag number, all standardized in P&IDs 5.1. Example bubble breakdown. Circle is your field instrument, e.g. transmitter. Letters. PT equals pressure transmitter. TT equals temperature transmitter. Numbers. Match with the loop ID. Real world. A poorly labeled or non-standard bubble can derail hours of troubleshooting. NEMA-based diagrams sometimes show more physical layout, IEC style often abstract, but easier to draw digitally and scale. Tips for reading across standards. Watch for mixed standards in international sites. Tip No. 1. Use the title block. It often specifies if it's ANSI, NEMA, or IEC. Tip No. 2. When in doubt, trace the signal, not the symbol. Voltage and current don't lie. Tip No. 3. Practice redrawing a NEMA loop in IEC format and vice versa. It's a great learning tool. Tip No. 4. Always carry a legend or reference key when starting at a new facility. Wrap-up schematics are the language of our trade. Knowing both NEMA and IEC gives you an edge, and decoding loop diagrams turns you from reader to interpreter. Like this deep dive? Hit like and subscribe for more videos made for real techs. Next time, we'll jump into voltage and current sources, symbols, models, and the misconceptions that throw people off. And don't forget to check out our Facebook group for more resources, diagrams, and discussion.